All right. So first of all, apologize for not reaching out. We're supposed to have this on the we're supposed to have this on Monday, but I had a very busy weekend and I needed to get some things done earlier in the week. So that was essentially why I didn't reach out. So I figured you guys have gone through the materials, you have an understanding of what the assignments are. I'm sure I don't think I've gotten any. Oh, sorry, excuse me. I don't think I've gotten any submissions for any of the assignments yet. There are just three of them. There's somebody has done one for the BMI calculator, for the H calculator, and for the Pythagorean theorem. Okay, so only one person has turned their assignments in, and the deadline should be for this Saturday. I gave you 2 weeks essentially so that you have more time. So hopefully by Saturday, today's already Thursday, you have Friday and then you have Saturday. Hopefully by Saturday, I would see more submissions. So what else do I got to say? Right, so let's begin. Let me just go through what exactly this week what we're talking about this week. And if you look at the syllabus, it says operators and expressions. Now, ideally, during the Q&A session, what should happen is that you should have reviewed these materials already. Should have taken a look at the assignments. So when we come for this meeting, all I'll be doing is answering questions. But I'm guessing nobody has any questions. Or let me just ask, does anybody have any questions as regards the materials on operators and expressions? I'll ask again, does anyone have any questions as regards the materials on operators and expressions?
No.
So you understood it very well?
Yes, yes.
Okay. So if that's the case, is there a reason why you've not done the assignments or the task?
I'm still working on the first last task 5.
Okay. All right. Sharon, thank you for your input. I'm guessing Obina, you're the one that made the submissions, right?
Yes.
Okay. All right. Mr. Kenny, any questions from your end? Mr. Kenny? I'm not sure you can hear us. Timmy, can you hear me? Okay, so Mr. Kenny and Timmy are currently not online, I guess. Probably they're muted or something. So I did, like I said, you should have asked questions and then I'll just answer them. But so far, Shehu says he understands the material. For Obina to have submitted this task, that means he understands the material. I'm just going to give like a general overview of what operators and expressions are. So, if you're having any challenges, then you can, maybe this will help or something. So operators and expressions are kind of the common concepts in programming. They're kind of the building block for a lot of the languages that you do. Every language that you have, every programming language, every code rather that you write are forms of expressions, statements as well. So I think some languages call them statements or something. So they're a form of expression. So each line, I'm just going to show you a quick example. Don't get mad, don't get carried away by how complicated this line of codes are, but this is a programming, this is a Python program, for instance. And each line is an expression, sorry, is a statement. And a statement can either be an expression or an operation, or I think those are the only two things. If you start trying to go into the dynamics of which is which, you probably just get lost. But the idea here is that, I'm just going to open one this way. The idea here is that there are some operators that you need to get familiar with. Stuff like arithmetic operations, addition, subtraction, multiplications, divisions, modulus. Modulus is basically when you have to divide, when you want to get the quotient of a division. And what I mean by that is, if I open my Python, for instance, basically, if you say 9/4 what would be your output in your ideal? Why is this working for me? Oh, say 9 over 4, you get a decimal number that says 2.25. And then if you say 9 double divided 4, what you get is 2. And this is basically called modulus, I think. Yeah. I'm not sure, I can't remember the name. But this one gets you the quotient. Basically, how many 4s can you see in 9 without the remainder? Basically, they remove the decimal part. If you want to get the number of remainders when you divide 9 by 4, what you use instead is percentage. And that tells you that when you divide 9 by 4, you get a percentage of 1. When you divide 9 by 4, the quotient is 2. If you don't know what quotient means, I don't think I can explain that. That's mathematics. All right. So all of this is I'm saying, if you review this, if you review the videos attached, or you review the links attached, you understand exactly what I'm saying. So I'm not going to go too deeply into that. But those are what operators are. Sorry, those are operators: plus, addition, subtractions. You will also have some other complicated operations like these ones. For these ones, don't stress yourself too much. If you understand it, then that's great. We're going to talk some more about it when we get to lists and arrays and all that stuff. They will also have how to work with booleans. Booleans is a very important thing, true and false. Last week we talked about data types. We talked about Boolean data type. I mentioned that they are true and false. Now, if you did mathematics or engineering or logic, you know that there are some kind of stuff that you can do where you say true or false, true and false, stuff like that. I'll give you a bit more context. If I give you 2 different conditions for something, and I say that both of those conditions have to be true before you can do a thing, then what I'm basically saying is that this has to be true, and emphasis on and something else has to be true. So just to give you an example, if I said old is true, and I said married is false, but then I want to know if you can apply for loan. What I'm going to basically ask is if you are old and you are married, this is basically how you write it. So if a person is old, in this case true, and the person is married, then the person can apply for loan. But if the person is old but is not married, he cannot apply for loan. If the person is married but is not old, he cannot apply for loan. And basically means that both of them have to be true before you can do something. Do you guys understand what I'm saying?
Yes.
Good. Now,
Yes.
awesome. Good. Now, if I was about to try something else and say president of department, let me say final here, let me put this, level 500. Actually, let's not do that. Yeah, let's do that. Sorry, let's just do that. Level 500. What else do we use? What else do we use? Students. Is a student, then you say that's supposed to be true. Now, the person can be president if the person is in 500 level. Now, this is where it gets tricky. This is a condition. This is a Boolean here. This basically says if you watch the materials of the operators and expressions, you know that what this is evaluating to is true or false. Basically saying that his level equals to 500. Now, what I'm trying to develop here is now saying if the person's level is equals to 500 and is a student, then he can be president. So by the time you print out the value of president, you see it says true. But if, for instance, I were to change the level to 400, for instance, and I try to run this code again. I'm just going to copy this down there. Obviously, you guys don't write your code like this, so I'm just doing this to explain. When you're writing your code, you're supposed to go to file and new file, just as a reminder. So if I run this again and I try to print the value of can president, it says false because one of them is false. The level is not equal to 400. Do you understand? Do you guys understand that?
Yes.
Okay. Now, what if I wanted to say that's not fair? The person doesn't have to be both 500 level and has to be a student. What if I wanted to make it one of anyone, like either of them? Is either the person is 500 or the person is a student or the person is both. In that case, that's where the or operator comes in. And what you do then is rather than have and, you have or. So basically, if the person is a 500, it doesn't matter if he's a student or not. Well, ideally, no, logically, obviously, he's a student. But for this particular example, what I'm basically trying to say is that when you use an or operator, as long as one of them is true, everything evaluates to true. When you use an and operator, as long as one of them is false, everything is false. So I hope that when you read these materials and you watch these videos, they will able to explain all of that to you. Now, I'm not going to go a lot into details really, because at the end of the day, it's really just everything is in your hands. I expected that you have questions for me, but since there are no questions, what I'll do now is explain what the tasks are, and then hopefully that gives you a bit more insight into what you're trying to do or what you're supposed to do. So for the BMI calculator, many of us are probably familiar with the formula that says weight over height. I couldn't put the image in the stuff inside the question, so I had to attach it. So if you open this formula, it says weight over height. And basically, what I need you to do is accept an input from a user that is the value for their weight. Also accept an input for the user that is value for their height. Calculate it, calculate the BMI, determine and then display the user's BMI. Now, some of you might just calculate the BMI 25.5 and then print it, and that would be good. But something you can do to take it a step further, and I'm pretty sure Obina might have done this. You can just do a bit of research about the BMI rate. I don't think I've taught you if and else yet, so it might not be a good idea to do it. Okay, let's not do that. If you know if and else conditions, then maybe you can try this. But I don't think it's possible to do that now. No. Okay, you know what? Just calculate the BMI and then print it out to the screen. If you want to take it a bit further, then be my guest. You can be creative. You can let the user enter their value for weight in pounds, because in the US, for instance, they don't measure their weight in kg, they measure their weight in pounds. So you can let the user enter their value in pounds, and then you probably have to do some conversion. And let them enter their value of height in inches, because I think some countries do that as well. So that's your BMI calculator. Any questions before I go on?
None from me.
All right. So for the age calculator, last time we worked on something on the script for age calculator, which was task 3 of week 2. Basically, what we assumed was that the person had done their birthday for that year. We assumed that. Now, what I want you to now do is now write a more precise program that will calculate the age of a person. Basically, the person is going to give you the month of their birth. Sorry, let me read that again. Allow user enter month of their birth as an integer. So basically, if it's January, they enter 1. If it's February, they enter 2, on and on, until December, where they enter 12. Also allow the user to enter the exact date of their birth month. So basically, if it's the first of a particular month, they enter 1 and then on to 30. Now, in this case, we're assuming that all months have 30. Obviously, some months don't, like September is 30, I think. November is 31. April is 30. February on a leap year is 28. So there are a lot of inconsistency. And if you're starting to write program for all of those inconsistencies, you'll probably waste time there. So assume that all of the months have the same number of days, which is 30. And then you ask the user to enter the exact date. So for instance, if my birthday is 26th of April, the month I will enter will be 4, and the date I will enter will be 26. Now, what I want you to do, obviously, in the previous code you've written, the user has already entered their year. Now, you're not going to take those 3 information, the date, the month, and the year, and then now calculate the user's age with more precision. And when I mean more precision, I basically mean that you're not going to take into consideration if the person has done their birthday for that year. So for me, for instance, if I put in 26th of April, 1995, I'm expected to see the age 26 because I've done my birthday for this year. When somebody enters the 1st of December, 1995, is expected to see 25 because he hasn't done his birthday this year. So that's the precision I'm trying to talk about. To reiterate, the major difference is that last time we only wrote a program that once the person enters their year, we assume that the person has done their birthday for that year, and then we'll calculate it and say, okay, assuming you've done your birthday, this is your age. But now we're not taking a step further. Given everything you learn about operators and expressions, you're going to take a step further where you ask the user for their date and their day, their month and their date of birth, and then now calculate to precision what their age is. Now, this particular question is going to be the tricky one, and that's mostly because I'd like to see what you guys come up with. Let me just put it that way. I'd like to see what you come up with, essentially, because the last set of people I did this with, there were a lot of, sorry, excuse me. There was a lot of perspective on how everybody went around their program. So hopefully you guys will give me a whole new, fresh perspective rather to look at this. Are there any questions about task 6 before I go on?
I have a question.
Sure.
Now, you said this age calculator. If you're going to do the calculation for this age calculator, I'm going to do the calculation for the date, calculation for the month, and for the year separately. Well, I don't understand.
All right.
Because so you should give the exact date of birth.
Yes. Basically, what I'll say is that in the last program you wrote, your person only entered their year. Remember that one? From last 2 weeks. Now, what I'm saying is that when we wrote that one, we assumed that the person did their birthday already. That was the general assumption. Now, what I want you to do is ask the user to enter 2 other things, the month and the day. So, for instance, 26 for 1995, 26 will be the year, the day rather, 4 will be the month, and then the year will be the year. Now, what I want you to do now is, unlike before, when we assume that the person had done their birthday, now you're going to now determine if the person has actually done their birthday. Well, actually, you're going to calculate the age, but then to more precision. So, for example, this person will be 26 because we already passed, the person has done their birthday for this year. Now, somebody who is 1st of December 1995 will be 25 because he hasn't done his birthday yet.
Okay.
Now, in the former program you wrote, the person will just enter 1995, and our program will output 26 because it assumed that they've done their birthday. But you see that the difference now is the person is going to enter 2 other things as well, which is month and day, and then you're going to use everything you know about operators and expressions to try to calculate the precise age. You can use this one as your example. So when you're done writing your program, you can try to use this set of inputs, see what it prints out, and then use this one, see what it prints out. If you don't get 26 and 25, then obviously something is wrong. You understand that?
Yeah.
Huh?
Yes.
Are you sure? Do you have any more questions?
No, for now, no.
Okay. Well, as usual, I'll be available throughout the week, if you have any questions. And then finally, Pythagorean theorem. That's basically simple. So basically, the Pythagorean theorem, I wish I had connected my phone. You know what's going to happen? I'm going to explain this in a different video because with the Pythagorean theorem, let me connect my notepad real quick. It's going to take me a minute to connect my notepad. I want to draw what you'd see. It would be easier if I connected my my notepad to it, so that way I can just draw what I want you to do. trick by okay. All right, so yeah, perfect. So now let me just read through that one more time. Given two lines. It says given two lines A and B. I'm going to put them side by side so that we can see. Okay. Given two lines A and B drawn on a Cartesian plane, the following rules apply. Line A has a starting point A, x1, y1, line B, that blah, blah, blah. Line A and B are parallel to each other. Write a program that, okay. Okay, so we have line A. Let me just draw this. Line A that has a starting point x1, y1. Obviously, you guys know the Cartesian plane, right?
Yeah.
Yeah, so this is x1, y1, and then has an ending point x2. Sorry, my drawing is not very straight. Y2, right? Now, we're going to have a second line. It said line B, x3, y3, and blah, blah, blah. Line A and B are parallel to each other. So let me just draw something as parallel as possible. Yeah, that looks parallel enough. Yeah, and it has a starting point x3, y3, and x4, y4. You guys understand this? You understand what I'm doing, right?
Mm-hmm.
Sheung, you're with me, right?
Yes.
Good. And you understand so far?
Yeah, really true. As you're going, I'll be understanding.
So these are three conditions. We have one line here, and then another line here, and they're parallel to each other. Now, it said, write a program that accepts this different value, x1, y1, x2, y2, x3, y3, x4, y4. You're collecting all those values from the users. And then you now calculate the distance of line A. For people that are not mathematicians, the way to calculate distance is by finding the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So in this case, you just take.
Oh, sorry. Can I come in?
Yes, please.
So this formula is just for calculating the distance between the two lines. Is that what you're saying?
No, calculating distance between the 2 points, not lines. So this is line A. To calculate the distance of line A, you have to calculate the distance between the 2 points. This point.
Okay, sure. Sorry. I was thinking of something else. I get it now.
Okay, so just to reiterate, the third part of the requirement says output the length of the line first.
Yes.
The length of line
I was
A,
thinking of diagonal.
Yeah. Then calculate the length of line B. Should you understand me so far?
Yes.
Okay, so I'm just showing you the formula. You can try to do your research. Just calculate the formula. So if in this case, this is 2, 3, and this is 7, 8. The length of the line will be square root of 8 minus 3 all squared plus 7 minus 2 all squared, in which case is 5 squared plus 5 squared. That's square root. That's square root of 50, which will give you something around 5 root 2 or something like that. Or you can find the calculator with diagonal or whatever. You can use the calculator to get the decimal value. So you do the same thing here. In this case, the formula will now be y4 minus y3 all squared plus x12 minus x3 all squared, then the square root. Does that make sense?
Sorry,
yes.
Sorry. Are we to give this x1 by 1 a particular number?
No, the user is going to enter them. I'm just showing you an example. This is just an example. The user will give you a value that you will enter according to these last two, and then you calculate it your program. No, she doesn't know. It's me that she's asking. All right. Can you mute your? Awesome. Thank you. So now you do the same thing for A, and then you do the same thing for B. Now, this is where the trick is. Output the length of the diagonal between parallel lines A and B.
Honestly, I couldn't.
Not done that part yet.
It's just I spent 4 hours and I couldn't get it. I think it's because I don't know if it's the formula or maybe I wasn't just anyway, just go.
Did you try to draw it out first?
Say?
Did you try to draw it out first?
Like you have here.
Yes.
Yes, I did.
Okay. Well, let's go.
I think it's okay. Yeah, let's just go.
Let's see. So the diagonal is basically, let me use a different color. This is black. Diagonal is basically this one to this point. That line is terribly drawn. And then this one to this one. That's even worse. So the length of the diagonal will now be the length between this point and this point. That means
fancy these points you're pointing out. Sorry.
Yeah, let me call this point B0 and B1. So basically B0 is the starting point, B1 is the ending point. This is A0, this is A1. The length of this diagonal will be the distance between B0 and A1. You just have to apply your formula again. But rather than these 2 points, you're now using this point and this point.
Oh wow.
Does that make sense?
Are you serious?
That's why I said if you scribbled it down, if you drew something out, you'll be able to see it, what you're supposed to do. So rather than do the distance of A, which is between X. Sorry, go ahead.
We're going to have 2 diagonals.
Exactly.
Oh wow.
2 diagonals. Because at the end of the day, you have one for this and then one for this. Shehu, you are lost there. You remain.
It's really lost too.
You are lost.
Yeah.
Well, I'll go over it again on the first sheet. Let me just open a new sheet. Okay, so let's try first follow. So let's say let me do something that would we'll use this one for the partition plane. Come on, man, straight to there we go. So I want to use a dull color for the partition plane, so it's not interfering with our diagrams. Let me draw the first line A like this. And starts A1, which is x1, y1, and A2, which is x2, y2. You understand that, right? I will give you the line A. So I need to make sure you understand it.
Yes.
Good. Now the next one says line B parallel to line A. So we just draw something parallel to line A. Is that's the starting point B0, B1 rather, which is x3, y3, and B2, which is x4, y4. You understood that now, okay? And that will give you B. You get that, right?
Yes.
Good. Now, we'll just stick in the endings. So that's you understood the formula about how to calculate the distance, which I'm just going to write that here again for iterations. D is equals to square root of y2 minus y1 all squared plus x2 minus x1 all squared. That's the formula. Now, to calculate the length of A, what's happening? Obina, what are you doing? Obina.
Sorry, I apologize for that. Sorry.
Oh, were you testing something?
Yes, sorry about that. Sorry.
No, it's fine. I actually want to know what you're testing.
No, it's fine.
Is it
I was
the
trying to make
annotation? Okay.
I was trying to get it's just something trick I was doing. I had no idea it was going to reflect on our scores.
I'm sorry about that.
I was
No,
thinking it was
thank
going to be
you. Yeah. So, to calculate the distance between two of a line, basically a line is basically a line joining 2 points. So when I say calculate the distance of a line, I'm basically saying calculate the distance of 2 points. So to calculate the distance of A, just asking to use this formula and apply it to these 2 points, this one and this one. You got that right?
Yeah.
Same thing for B. I asked you to calculate the distance for B. Basically, I asked you to use this formula again for this point and this point. You got that now?
Yes.
Now, the next part says the diagonals between the two lines. Now, diagonal, maybe it's not the right word, but essentially diagonal is the line joining one edge to the other edge, to the opposite edge. So basically, if you have like a triangle like this, so excuse me, the diagonal is one joining one edge to the other edge, like that. So in this case, let me use a different color, orange. This is our diagonal, joining one edge to the other edge. Be straight, please. Like this. This is one diagonal. Just like in the triangle, you can have double diagonals too. In this case, the second diagonal will be this. Yep, that's terrible. Do you get that?
Yeah. Yes, yes.
Now, good. Now, for this first diagonal, let's call that D1. That's for this one here. Now, that the points here will be, the points joining D1 will be point B1 and point A2, right?
Okay.
These are the points here, B1
It's B1
and A2.
It's B1 and A2.
That's this
Okay,
diagonal.
yes, I've seen it, yes.
You see it, Abby? Now,
Yes.
for the second diagonal, that's this one. The line joining them are B2 and A1. Now, basically, to calculate the length of the diagonals, all you need to do is apply the formulas again. Except for the first diagonal, the points you're using are B1 and A2. And for the second diagonal, you're using B2 and A1. Did you get that?
Yes.
And that's it. So what Obina was now saying is that at the end of the day, you will end up with two diagonals. And so your program should output two lengths. You got that?
Oh, okay, yes.
Now, this is the trick about programming. Everything I've done so far, this whole explanation, you're not going to do it every time. Once you've done it once, all you need to do is write the program once and to continue to work. Unless maybe somebody decides to wake up one day and say the length between 2 points is a different formula, and so you have to change this formula. But unless that is so, once you write your program once, once you've understood the concept behind your program, and then you program it once, you will ideally not have to rewrite it again. You might be doing some upgrades, some maintenance, but you're not going to scratch it down and then write it all over again. Now, why am I saying that? Because at the end of the day, when you're writing your program, you're not going to be drawing all these things that I'm doing right now. You're simply just going to ask the user for X1, Y1, X2, Y2, X3, Y3, X4, Y4, and then apply the formulas wherever appropriate. But to be able to know what to show your user, we needed to first draw the diagonal and say, okay, when our output of A, we're going to apply this formula for X1, Y1, X2, Y2. When we're doing the output of B, we're going to apply this formula for this and this. When we're doing the output of diagonal 1, we're going to apply the formula for A1. And, it's just for you to know what exactly you're going to be doing. At the end of the day, your user is not going to see all of this jargon that we're designing. All it's going to see is that it's going to enter a number, and then your program is going to bring out an output. Let me even shock you a bit more. You as a programmer, once you've done this once, you're not going to do it again. So that means that if you write this program, well, for life is a bit of a stretch, but yeah, something like that. But if you write this program and you give it to another developer, that developer has to go and, except he already knows, you have to go and start understanding exactly what the concept behind your program is. Understand that, basically bring out his own paper and start designing and start writing. Not because he wants to write his own program, no, but so that he can understand what you exactly are doing. For something like this, it is simple. So you might not need to bring out the paper. I mean, if you give me a code that does it, I'll probably look at it and say, okay, this is what it's doing. But then if you have a very large set of code, for instance, if I, in my company, for instance, these are all the files that we have running currently. We have a lot of lines of code. Now, if somebody else comes over and decides that he wants to start working with us, how is he going to know what is this one doing and what is that doing? This is a bit advanced. When you get to much more higher level programming, then you now start dealing, and this is where the whole idea of management comes in. Because for something like Cartesian plane, it is easy, one person can do that. But when you are developing an application that is going to be used internationally, that's going to be used by millions of people, for instance, Netflix, Facebook, and then features are going to be shared in different ways, you need to have a group of people that will be managing how the program will work. Those managers are the ones that will be doing the scribbling down, the writing on the paper. When they are done with the writing on the paper, they will give the programmers the formula. Essentially, what I'm saying is that the managers, the project managers, the product managers, the technical leaders, technical officers, those ones are the ones that will sit down, write on paper what needs to be done, try to understand the concept, then come up with the algorithm. Essentially, that's what this formula is, an algorithm. Or basically, that's what I'm basically trying to do here. They come up with the algorithm, and they tell the programmer, take, this is what you need to do. So that's what I'm talking about, bigger projects. And those are the people that get paid more. Fortunately, it's not very easy to just be a technical lead or a project manager. For many software companies, they prefer somebody who already has a bit of experience as a programmer. The reason why I'm saying that is because if in the future you decide that you just want to do programming for like 10 years and then become a tech lead, oh, by the way, there's a lot of money there. Like people get paid a lot there. If you decide that you want to do programming for a few years and then become a project manager, a tech lead, or an enterprise architecture, that's also a career path. Although I know some people decide that they want to do programming for the rest of their life. It's not also a problem. But if it's something you are considering, just check out, Google has a new thing that they are doing. Google. I think they're offering a course on project management. So basically what Google is doing now is that you don't have to go to school to have a certificate. You can take their courses for 6 months and they have a certificate. Okay, so this is one on IT support, there's one on data analytics, there's one on project management, the one on UX design, Android development. I'm actually currently taking the one on project management. And for that one, you have to go to Coursera to take it, I think. Yes, on Coursera. You have to complete 6 courses, blah, blah, blah. Ideally, you need to finish them in 6 months. And when you're done, you have a certificate that makes you just as employable as somebody who went to school. Now, imagine you have that certificate and you're not a programmer. And then you have a certificate from Google that says you're a project manager as well. I'm not guaranteed that you get you a job, but I can guarantee that you give you an advantage. So the reason I say that is because when you start programming, don't look at programming like, okay, that's now the ultimate goal. No. I've been programming for 3 years now, and I'm already thinking about what next to do, trying to get a management course, trying to get a management certificate so that when you apply for jobs, you can play the more big picture guy. Like I said here, the technical guys, the technical lead, the project managers are the ones that will come and scribble on paper that will try to understand the concept. When they are done, they will now give the algorithm to the programmers. Now, the problem about that is that programmers cannot see the full picture. They can only see what is given to them. The managers are the one that understands how the app works and how it fits into the company. You understand what I'm saying?
Yeah.
I'm sorry, I feel like I've been talking a lot, but do you guys get me?
No, please, go on.
Okay. All right. So programmers don't see the full picture. They only see what has been given to them, right? And it's not a bad thing, obviously, but some of us, for me, for instance, I'm not really that kind of person, a cog in the wheel or stuff. I like to be able to see the whole thing I'm working on, the entire benefits, and then able to see how things are moving in the grand scale. And so I always like the fact that currently that's one of the good things about where I work now. Well, I'm the only person working, so I'm in charge of seeing the full picture, basically. So it allows me this opportunity to feel like I'm a part of something. Some programmers don't mind the fact that some programmers don't actually mind that they don't see the full pictures. At the end of the day, it's what motivates you. But if you feel like you're a kind of person who wants to be able to see the full picture, wants to be able to coordinate how resources are used and managed amongst people, then you might want to consider a management program. Not now, maybe not next year, maybe not next 2 years, but it's just something you want to keep at the back of your mind. You can check out some courses. You can go to, I don't know, I think that are the only two I know. Google is doing one. PMP is also doing one. I think that one is a more recognized form of project management. For software development, for programming, I think the one they use is Scrum Master, yes. There's a certificate for that as well. So if you're a kind of person who believes in certificates and putting all these stuff to your belt, this is also another option you can consider. So I hope this 3 points of mine. I didn't even know what my point was. My point was essentially that programming
is duly noted.
Programming in itself is a good thing, yes, but there's still more stuff to it.
There's more to it.
Yeah. So that's everything I have to say. Do you have any questions?
I'm perfect.
Yes, I have another question too.
Okay.
It might sound, I think the question that I want to ask kind of going to sound absurd, but I'm seeing the calculations you gave for the formula for the y2 minus y1 raised to power 2. Now, when we are doing this, on the Python stuff, how are we going to do this raised to power? How are we going to calculate? Are we going to calculate this power, this
Yes.
square root ourselves? We're going to type it as a code.
Very good question. Very good question.
Shell.
I like that. So if you read operators and expressions, ideally, what do you call this thing? I've forgotten the name now. Carrots means power.
Did you call it carrot? Sorry.
I think that's what it's called. I don't think that's carrots. I think it's double carrots.
I thought it was called asterisk.
Oh, asterisk, yes. Double asterisk. Yes. So, but this carrot return an answer. That's a very interesting thing. What? Okay, now I need to research them. No, it's weird. I typed in carrots and then it returned an answer. So, but I've never used it before.
Okay.
Doesn't really check what it does. Oh, it does something, Sha. Man, I've never done this before. But nobody's saying what it does.
You're welcome.
Okay. Nobody's saying anything about it. They just put it there. They didn't really talk much about it. I'll do my research about that anyway. Don't let me get distracted. So what you are asking for is power. To do power in Python, what you do is asterisk, double asterisk. So 8 double asterisk 2 is 8 raised to power 2. That's 64. And if you're a mathematician,
how about the square root?
Square root, if you're a mathematician, you know that square root is basically raised to power 1 over 2. So you can say 8 raised to power 0.5. Sorry, let me know you see. Let me use 25. That will give you 5. Or you can say 25 raised to power 1 over 2. Same thing. Just make sure you put inside a bracket. Give you 5 as well. But if you want to use there's a library called maths that you can use as well.
Math.square.
Math.square, yes. Square. No. I need to start researching.
I think it's SQRT.
That's square root. That should be square root. Yes, that's square root. I was hoping there would be square. There's no square. But if you wanted to use some other, like square root, for instance, because there's a particular module. I don't want to start teaching about this now because I'm going to do it later. But there is a particular module in Python called maths that has all of these tools that you can use. But you have to import it at the beginning. So you have to, if you write a program, for instance, let's assume this is a script, you have to put it at the beginning, import math at the beginning. And then anywhere you want to use it, you just find what you import, put a dot in front of it. If you're using something like Visual Studio Code, it will immediately show you things that you can import. But with Haidu, you might wait a bit. So you can even see Haidu has brought some things out. You can find the cos, the A cos, the arc cos, the arc sine, the arctan, the cos, the cost, V, blah, blah, blah. Then you can even just take a quick check for S. Oh, there's just square root, there's no square. And there's even pi, there's even log. But you know, this might be a bit complicated, so you can just stick to the simple this is 0.2, like that. Oh shit. Can you guys hear me?
Yeah.
Yes.
Cheryl, does that answer your question?
Yes. Yes.
You have any
So
more
I believe
questions?
I've gotten the one for square root and the raised power 2. Okay.
Yes.
Thanks.
Any more questions?
No, if I have anyone else, maybe probably send you a message if after the
Sounds
talk.
good. In case, because I'm pretty sure others are going to listen to later, that's Mr. Kelly, Timmy, and Smith. I'm pretty sure, and then Godwin maybe. Really listen later. So I don't know what the status of the, maybe I'll chat you up at the group. I need to know how far you guys have come and then know if you need extra time. But just keep in mind that if you have some extra time, then we'll talk about that when the time comes. Anyway, thank you all for coming tonight. Have a good night. As I usually say, I'm available for questions anytime during the week. I may not respond immediately, but I'll try to respond as soon as I can. Thank you again.
Thank you very much. Good night.
Cheers.